Hello everyone, in today's video I'll show you how to calculate the liquid limit step by step. We calculate the liquid limit by finding the moisture content at 4 penetration points using the Cone Penetrometer Method. Now, after calculating the moisture content for each penetration, a graph of moisture content against penetration will be plotted, and from this graph the liquid limit will be determined at 0.20 millimeter penetration. So at every penetration point, that is 16, 18, 20 and 22, we are calculating the moisture content. Now as you can see here, we're doing the calculation. We have the mass of wet plus the tin, mass of dry plus the tin, and we have the mass of the tin that will help us to calculate all the moisture content at these 4 points. See now, the mass of wet minus dry, we get the water, as you can see here. Then mass of dry minus mass of tin, you get the dry sample. Now at penetration 16.2, the wet weight is 46, the one that we got before oven drying. Then after oven dry, we got 36, the dry soil plus the tin weight. Then when you subtract, get mass of water, that is 10. Then we have the mass of dry plus tin is 36. When you subtract mass of tin, we get mass of dry, that is 18.5. So how do we get the moisture content in percentage? We calculate it by mass of water over mass of dry, you multiply by 100, so you get moisture content in percentage. So we calculate all the 4 points like this, and then we will have 4 moisture content at the end, which will help us to draw our graph, to plot our graph, and from there we will obtain our liquid limit. So the value that will be corresponding to 20 millimeter penetration, that's where our liquid limit we obtain from. So when we calculate we use M1, M2, M3, M4, M5. So M1 is the mass of tin, that is M1. M2 is the mass of tin plus wet sample. M3 is the mass of tin plus dry sample. Then we have M4. M4 is the mass of water that will be obtained from M2. So that is, water is wet weight minus dry weight. That's where we get M4. Then we have M5, the mass of dry sample that will be obtained from the mass of dry minus the tin weight. So this, in this, you can also write it as in, because the moisture content, you get it, we write it as M4 over M5 times 100, or you can write it directly M4. M4 is into bracket M2 minus M1, then over the mass of dry M3 minus M1, you multiply by 100. So from there, calculate all the other 4 points now, so that we can get those 4 moisture content, so that we can be able to plot our graph and get the liquid limit. So we have there, as you can see, we have the plastic limit already. We had calculated it, PL, and also we had our shrinkage from the trough. So we have those 2 points. Now we want the liquid limit so that we can calculate our PI. Just a quick reminder, our liquid limit is the water content at which a soil changes from a plastic state to a liquid state. In practical terms, it is the water content at which the soil starts to flow under its own weight. So as you can see there, we are plotting the 4 points so that we can obtain the liquid limit. So liquid limit is one of the Atterberg limit that represent the upper boundary of the plastic state. So as you can see, we have obtained we have the liquid limit, we have the plastic limit, now we have subtracted, this is our PI, 23%. Thus, and we had our shrinkage limit. Thank you for watching. So we have seen our plasticity index, PI is equals to liquid limit minus plastic limit. PI is equals to LL minus PL. In our case, this is 58 minus 35 is equals to 23%. Unlike the Cassagrade method, the liquid limit here is obtained at 20 millimeter penetration using the cone penetrometer. So thank you for watching. Don't forget to like and subscribe.